Hi, in this video, I'm looking at this combinations problem here, where we're trying to make four-letter selections from the letters A, B, C, D, E, F, and G without any repetition, but the letter B must be used. So basically, I want to pick four letters out of these seven letters, but B must be in there. So if I think about drawing one of these words, I want four letters to make up a word or a combination, a selection, but one of them must be that letter B. So I've used the letter B from the problem, which means that I've only got the letter A, C, D, E, F, or G to pick for my next letter that I might randomly select. So I've got 1, 2, 3, 4, 5, 6 left. So that means there's 6 letters that could be picked for the next letter in the problem. And then I've used up one of those letters, meaning that there's 5 letters left. And then I've used up one of those letters, which means I've got 4 letters left. So that would mean that the number of combinations for this one would total up, well, got one option to pick the B. That must be in there. And then multiply that by 6 times 5 times 4, which works out to be 120 different ways to select 4 letters from these 7 if the B is the first character selected, because that's the situation I've represented here. B came first, then I randomly selected the others. I can look at this same problem by positioning B in different places then to think about all the different ways, because B could come second, or B could come third, or B could come last. That's my possible options. But if I think about it, it doesn't matter where I place B. I still have, for my first of my other letters, I've still got 6 options. For my second of my other letter, I've still got 5 options. And for the final letter, I've still got 4 options. So that means that there's 120 ways, depending on where I place B. If B comes first, 120 ways. B comes third, 120 ways. So that means that the grand total would be to add all of these up. So the total number of combinations is 120 plus 120 plus 120, or just do 120 times by 4. So there's 480 total possible selections that we can make that are 4 letters long from these 7 letters if B must be one of the letters somewhere within that selection. We don't really care where it turns up, but if we account for all the possible different positions of B, and then we can work out how many combinations of the other letters fit in, giving us a grand total overall if we add them all up.